So let's consider v1 is equal to 0, 0. v2 is equal to -1, -1. And v3 is equal to 2, 1. Question. Is the set of these vectors linearly independent or dependent? Well, formally speaking, what does it mean to be linearly dependent?
Make one with the linear combination of the other.
You can isolate one of them and write it as a linear combination of the other ones. What does it mean to write one vector as a linear combination of two other vectors?
Scalar vectors.
There exists a set of scalars that you can choose to scalar vector multiply other vectors in that set to produce the vector that you had. Let's try this one. Can you produce v3 as a linear combination of v1 and v2? Okay, so let's do this. We're not sure about this. Is v3 linear, now we're going to use the first context, linearly dependent on v1 and v2? Well, if it was, we could write what? We could write v3 is equal to x1 times v1 plus x2 times v2 for some x sub k in R. And what would that mean? I could multiply a scalar times 0, 0 and another scalar times 2, 1, and what vector would I get out? Why would that not be possible?
Did you try -1 for x?
Did I mix them up? Sorry. Why would that not be possible? Why can I not multiply these two vectors by some random scalars and get this thing back? What happens when I multiply 0, 0 by any scalar? I get 0. So no new information's here, right? So that means the only way that this would happen is if I can find a single scalar, multiply it by the vector -1, -1, and get the vector 2, 1. What's the likeliness that that would happen?
Possible.
Why is it 0?
Because they have to be the same number.
Any scalar multiple times this, draw the span of this vector in the air for me. It's the line that goes 1, 1, right? The first and second coordinates always have to be equal, which says what about this thing?
No.
It cannot be in this span, which means v3 can definitely not be written as a linear combination of v1 and v2. Have I concluded that the set v1, v2, v3 is linearly dependent?
No.
No. What did I conclude?
That specific one.
That v3 is linearly independent from v1 and v2. Okay. What's the next thing? Does anybody see a flash of inspiration just from doing this analysis? Do you see a flash of inspiration on something that might give you a hint about whether or not that set is linearly dependent or linearly independent? What's the flash of inspiration you see? Okay, so you said that v1 was equal to 0, 0. It gives no new information from the standpoint of the span because no matter what I multiply, I always get back 0, 0. So there's no additional vector that I would get out of that. Could you guess what linear combination of the other two vectors you might need to take to get the 0, 0 vector out? If I took x1 times v2 and I multiplied that, I guess I could do x2 times v2 and x3 times v3, well, what would that be? -1, -1 plus 2, 1. What's the claim?
x2 and x3.
What would I immediately see in that situation? That the vector v1 is linearly dependent on the vectors v2 and v3, and because I can isolate one of the vectors as a linear combination of the other vectors, in other words, I have there exists v sub j equal to the sum of all the other vectors, k goes from 1 to n, where k is not equal to j, of x sub k times, in this case instead of a, what would it be? V sub k. What's the claim there? A linearly dependent set of vectors. What is it? It's a set of vectors where I can isolate one of the vectors and write it as a linear combination of the other vectors. Does that mean that I have to write could I write v3 as a linear combination of v1 and v2? No. Could I write v2 as a linear combination of v1 and v3? No. But at least one of those vectors could be written as a linear combination of the other ones. In this case, it's unique, right? Only v1 can be written as a linear combination of v2 and v3. And the moment I can do that, the moment I can isolate one and write it as a linear combination of the other ones, the ones that aren't used, what do I call the entire set? Which says what about the span? The vector that you can isolate, the vector that is extra, doesn't add any new information to the original set.